Hello, my name is Allison Gatt, and this is my presentation on the conservation of the Florida panther, specifically overcoming population bottlenecks. Firstly, the Florida panther. It is a subspecies of puma, sometimes called cougars, that is native to the eastern United States. This specific population is only found in southern Florida. You can see here on the map on the bottom that dark purple area is the present range of the Florida panther. The light purple is the historic range. So I do want to clarify that pumas and cougars are native to other areas. It's just this one specific population of Florida panther that is only found in this region. So firstly, I want to go over what a population bottleneck is. This is a sudden, drastic decrease in the number of individuals in a population. This can occur because of many different things, any external factors that cause this population to suddenly lose quite a few of its numbers. This presents an issue with maintaining the genetic diversity since the effects of drift are more pronounced in small populations. I'm going to go over in a later slide what population drift exactly is. But for now, I just want you to look at the upper right image. This very well highlights what a population bottleneck does. You can see the original population and only a few members make up the surviving population. And the new population that comes from the surviving population is actually very genetically different from the original population. The Florida panther underwent its own population bottleneck, and by the 1990s, there were only 20 to 25 adults that were found in this population. When a species undergoes a population event or a bottleneck event, the two options are that it goes through recovery and likely the new population will be different from the original population, or it goes on to extinction. So some of the problems that faced the Florida panther population following their population bottleneck was genetic drift and inbreeding depression. Genetic drift is the effect of random chance on a population. It is the random changes and fluctuation in alleles that cause them to either be fixed or lost in a population. The lower right corner, you can see this illustrated just with the red, yellow, and blue dots. As you can see in the original population, it's pretty evenly divided, but as time goes on, just because of random chance, some individuals producing more than others, others not producing at all, the final generation has no more red and is completely just the blue and yellow. This is what genetic drift does. Inbreeding depression is a reduction in fitness from offspring being produced by related individuals. This can decrease heterozygosity and increase homozygosity, and this is more pronounced in small populations like the Florida panther population. You can see in the right corner, this is a chart kind of showing how inbreeding depression works. The main issue with this is that recessive alleles that are harmful to the individual and impact their fitness, instead of being masked by a dominant allele, tend to be shown in the individual produced because this individual is homozygous for this allele, as you can see by that chart. In the Florida panther population, this was seen to be true as a lot of abnormalities started to be present in this population, including low sperm count, undescended testicles, and atrial septal defects. These are all very detrimental to the survival of the Florida panther and are due to this inbreeding depression. Genetic restoration, the introduction of Texas pumas. So in order to combat this inbreeding depression and the effects of genetic drift following this population bottleneck, several Texas pumas were introduced into the population of Florida panthers. This is called genetic introgression. This is introducing genetic admixture among individuals from different populations. So from the population of Texas pumas, which is Puma concolorus stanleyana, 8 of these were taken and introduced to the Florida panther population. And of these 8, 6 were found to breed with the Florida panthers. These are genetically different enough that the hope was that they would cause the Florida panther population to be more genetically diverse. but also genetically similar enough that they could actually breed with one another. You can see here, this is a very good example of what genetic introgression and genetic admixture looks like here. You can see population A and population B shown. And as generations go on, you can see that population C has become more genetically diverse than population A or population B. In the case of the Florida panther, the outcome of this introduction of this Texas pumas was higher survival rates and genetic diversity for the hybrids, indicating success of this undertaking and helping the Florida panther recover from this population bottleneck. Ongoing efforts. So there still needs to be ongoing efforts to preserve the Florida panther population. This population is still a relatively small, very isolated population, which poses a risk of future population bottlenecks. It is unlikely for natural migration to occur into this population. You can see in the orange is the current range of cougars, which is what the Florida panther is a subspecies of. And you can see the small bit of orange that is in Florida, that's the Florida panther population. As you can tell just by geographic distance, there is very little likelihood of a individual from one of those other populations making its way to Florida, to the Florida panther population. So to combat this and to continue bringing in genetic diversity into this population, it has been suggested that 5 to 10 individuals from these other populations are taken and introduced to the Florida panther population every 20 to 40 years to continue that population admixture and continue to promote genetic diversity in the population. So, conclusion, the genetic intervention following the population bottleneck of the Florida panther was indeed a success. The hybrids showed a higher level of survival, and their population numbers have continued to grow. Without this, studies have shown that it is very likely the Florida panther would have undergone extinction without this intervention, and continued efforts need to be made due to the isolated nature of this population. Here are my references. Thank you so much for listening.